This meeting is being recorded.
For chapter 19, problem 22, we're asked to take a look at this reaction and draw out the mechanism for the formation of the product that we predict to form. So this is a two-step mechanism. So I've outlined the steps below here. So for step one, let's review. We have acidic conditions. We're treating a secondary ketone with hydrazine, and we will have water lost. So let's walk through the first part of this reaction, the first step. So what we see here in the first step is that hydrazine functions as a nucleophile. So that's what we see over here. So this is our hydrazine. We have a nucleophilic attack in step one. And again, this is just the general form of our ketone. So we know that our groups will be slightly different. Now that we have that nucleophilic attack, our intermediate is then protonated. So this is our intermediate here. We see this proton transfer occur, again, from our hydrazine. Then we have formation of this the carbanolamine here. And then again, we see another proton transfer occur involving our hydrazine. That will give us this compound over here. And we see that through another proton transfer, once again, using our hydrazine here, we will then form a better leaving group. So we have water here. And then in this process, or in this step of the mechanism, we see this intramolecular rearrangement and loss of that leaving group here. So water is gone. Now I have my iminium ion here. It's like an amine rather, but it's ionic. So then we have one last proton transfer here from, once again, hydrazine, and we produce this hydrazone product. So now that we have our hydrazone product produced after step one, we then can look at our mechanism for the second half of this problem. So we have potassium hydroxide in water, so basic conditions, and heat. So what happens here is under these basic conditions, the hydrazone is reduced through the mechanism that's given in 19.8. Through this reduction, and we see that again our starting material here, our hydrazone in basic conditions, will be deprotonated, and then we have this resonance stabilized intermediate. We have a proton transfer here, we have another proton transfer shown here, and then through another proton transfer here, so we have 3 proton transfers in a row. We can see that through intermolecular rearrangement here, we have our leaving group here. So we will lose nitrogen gas, so loss of N2. And then this produces a carbanion intermediate here. And again, another proton transfer is seen. This reproduces our hydroxide in this last proton transfer, and we create our fully reduced product here.